Assalamu alaikum students, welcome to the Phys Maths Concepts. This is Shamsa Jameen and we are doing Cambridge IGCSE Paper 6 Physics Alternative to the Practical May June 2025 with the code 062562. Let's start with the question number 1. A student determines the internal diameter D of the test tube. Apparatus is shown in the figure. Okay, this is. Then in the A part, what they want from us, the students fills the Meyer cylinder with the water up to 100 centimeter cube mark. Pour some water from the Meyer cylinder into the test tube. Okay. A full size diagram of the bottom part of the test tube is shown in the figure. Okay, we can see it. So what they want from us on the figure 1.2, what they want from us, measure the height h in centimeter to the nearest millimeters. Okay, and we have to write this answer on the table. So first we will calculate this height h, right? So how we will calculate it? By using the ruler. You just need to place the ruler on this line and measure the length over here, right? This length from the ruler, measure this distance, and it comes out to be 3.4 centimeters, right? And we need to write this value here, 3.4 centimeters. Okay, now move to the second part. The figure 1.3 shows the volume of the water remaining in the cylinder. Okay, take the reading R of the, what is R? We need to take the reading R of the volume of the water remaining water in the measuring cylinder. Okay, so again we need to measure the level of the volume, level of the water, this one. And you can see that it is one step less than 80. So it is 89 centimeter cube, right? Again, what we need to do, record this answer in the table 1.1. So I think we should write it here, 8.9. Okay. Calculate the volume V of the water poured into the test tube. Equation is given. This is our equation, and we need to write we need to put the values and get the answer. So let's start it. V equals 200 minus 89, and it comes out to be 11 centimeter cube. Again, what we need to do, we need to write it on the table. So 11 centimeter cube. Okay, students, now let's read the question number B part. A student adds more water from the measuring cylinder into the test tube. Okay, suggest measure the new height h of the water in the test tube, new reading R, volume of the water V, and we repeat the procedure for the 3 more values. So you can see from here that we have the further values, readings for H, R and V, right? So the student results are shown in the figure. Okay, it is important now, it is important to avoid line of sight parallel axis when reading of the scale of a measuring cylinder. So how such errors are avoided? So whenever we have a parallax error, it means it's an error of a sight. And for that case, okay, either here one thing they also ask you, you may draw a diagram. It is very important. Whenever the examiner asks you for the you may draw, it means you should draw the diagram. You must draw it. So let's draw the diagram. Here we have a measuring cylinder with the volume in it, and this is our this is the level of the water, and whenever we need to measure it, it must be, this is the reading of the scale, right? Okay, I think I should change the color to give you the understanding. From here we measure the readings, right? Reading of the scale, volume of the height one, and this must be always perpendicular to the eye, right? Both of them should make an angle of 90 degree. So reading on the measuring cylinder, so how will explain it? Reading on, I was writing on, okay, of on measuring cylinder should be perpendicular to the eye, right? Okay, now move to the next part. Plot a graph v y-axis and h on the x-axis. Start your axis at the origin. This is very important, origin, right? And draw the best fit straight line. Okay, so students, let me change the color and start it. Okay, so let's start it with we have v, and v is in centimeter cubes. In x-axis we have h, and it is in centimeter. So students, whenever we need to start the graph, for plotting the graph, the scale we choose must be a multiple of 1, 2, 5, 10, right? So the selection of a scale is very important. I will just give you the overview, and if you still want a further explanation for the drawing the graph, you can comment me. I will make a separate video for that one, right, in detailed video. Here I will just give you a few points to understand the question. Okay, so let's go to the table. Here we can see from the height, I should choose yellow color. Okay, this is our minimum height 3.4, and this is our maximum height 13.6. So it means our x-axis scale must cover 16, 13 above, right? Scale must go 13 above. And for deciding it, here we can choose, if we take the 5 multiples, it will be 5, 10, 20. It's a very big scale. And for 1 it is not possible, so I think we should go to the 2, 4, 6, 8, 10, 12, 14 and 16, right? Okay, for the y1, our minimum value is 11 and the maximum value is 47. So we need the nearest value is like scale must cover up to 50. And one more thing, we can't break our scale, right? Mostly you can see if our value is starting from 11, so we can't start it from 11. We can't break our scale. Why? Because in the question they mentioned you that the origin is our 0, 0. Okay, so we will take the y-axis scale as 10, 20, 30, 40, 50 and 60. So let's come to the first value, that is first value is 3.4 and 11. So I am choosing, this is my 3.4 and 11, this point. Right? And then we have the second value 5 and 16. this is our 5. Where is 5? This is 5. If we go and 5 and 16, it comes out to be here. 5 and 16. No, I think it should be one step up. Yes, this one, right? Then we have 7.6 and 25. How I am finding it? One H value and one V value. I think I should make space so these things will be clear. Okay, let's start. 7.6 and 25. This is 7.6 and 25. Okay, then we have 10.3 and 10.3 and I think this is 36. 10.3, 36. 10.3, 1, 2, 3. Okay, and 36. 36 go up somewhere here. And then we have 13.6 and 47. 13.6 and 47. It must be here. 45, 46. This one. Right? I think I should remove the other lines, other dots, so we can focus on our table. Okay, so now join the lines for the best fit. Oh, no, sorry. Okay, I think I should use the ruler. Okay, something like this one, because it comes out, because if I try to fit it, few points go up and few comes in the line. Okay, let's make a line, right? So basically this is our line and this point is basically here. It is just an estimated line, right? It's a best fit line. Now I think we should move to the next part. Okay, I think I also, one more thing, I need to mention these scales specifically. In x-axis, which scale we take? One big box equals to 2 centimeters, and in y-axis we take one big box equals to 10 centimeter cube, right? Scale is mentioned, we label the numbers, we draw the points, and then we make the best fit. I think it's done. Okay, now let's come to the question number D. Determine the gradient D of your line showing all your working and indicate on the graph the value you use. Okay, I think for this one you all must have the calculator. Everyone open your calculator and we will choose the points. I am also opening it. Okay, so let's take it. I think I should use the color black. Okay, yes, so you can take any point from here. I think we should whenever we want to take the gradient, whenever we want to take the gradient, we must have the take the maximum portion of the line, right, to get the good value of the gradient. So I think we should use the last point is exactly the same. I am taking the exactly same point, that is which one is that one, 13.6 and 47, right? 13.6 and 47. And for the x-axis I want to take 5, and this one is I want to take this point. This is above the point we get, so it comes out 5, and the y-axis it is 10, 11, 12, 15, 16, 17. 5 and 17, yes, 5 and 17.5, something like this one, yes, 17.5, yes. Okay, so let's take the gradient. So g is del y2 minus y1 divided by x2 minus x1. So here I am just putting the value. Y2 is 47 minus 17.5 divided by 13.6 minus 5. 47 minus 17.5, 29.5, and the other value is 13 points. Everyone pause the video, do it by yourself, take any 2 point and check. Let's check how much our answer vary. It will be vary because everyone take the different points. 8.6, so 29.5 divided by 3.43. I get the answer 3.43. So students, check out your answer. Okay, meanwhile I will move to the next question. Let's start it. Okay, the internal diameter, the internal diameter of the d of a cylinder is given by equation this. Okay, formula is given, we just need to put the value. K value is given and calculate the d of the test tube. Okay, so how we will solve it? Just put the value. D equals to K value is 1.13, square root of G value is 3.43. Okay students, so do it on the calculator. I am also solving it. It comes out 1.13. We get the answer 2.0927. I think I should move to the one significant figure, 2.0927. So we can write it as 2.1 centimeters, right? Okay, now the next part, suggest one reason why your calculated value for D is only approximate. Okay, we have different reasons, but here it's a 1 mark question, so we need a one solid reason. You can write any of this one, I will explain you. It's your own choice, whatever you want to write. So the basically why we get different values, because of the this line of fit, right? Best fit straight line is vary for every person, right? So I can write it, or we can say that gradient is not accurate because this line give the value of gradient, right? Or we can say water might stuck with the measuring cylinder, that's why we don't get the exact values, it may vary. Okay, so here I am giving the first main reason is the line of best fit is an approximate. So obviously it gives you the approximate calculated value. Well students, I hope this question is clear. In the next video we will solve the next question. Meanwhile, if you guys have any confusion or any question, just comment it and I will reply back to you. Thank you. Allah Hafiz.